Welcome to Q&A with Qlik. Today we're going to be talking about Qlik Open Lakehouse. Just want to quickly introduce myself. My name's Troy Rainey. I help put together webinars and videos like this one. We've got a great expert panel for you today. I'll just quickly pass around, let you each introduce yourselves, starting with Antoine.
Thank you, Troy. So hi everybody, I'm Antoine Richard, calling from France. I'm a product manager working on Qlik Talent Cloud Pipelines and on Qlik Open Lakehouse.
Great. Jason.
Yeah, Jason Hall. I'm a solutions architect out of the Boston region. I've been at Qlik for about a year now. I came to Qlik through the Upsolver acquisition, which has provided much of the technology to drive Qlik Open Lakehouse.
Thanks. And VJ.
Hello, everyone. This is Vijay. I lead product marketing here at Qlik as part of the data business unit, and I'm specifically focused around Qlik Open Lakehouse. So excited to be here.
Awesome. Thank you. Well, when you registered for today's event, you got an opportunity to submit some questions ahead of time, and we've got a few of those we'll address first. So first question, what's the difference between a data lake and a data lake house?
Yeah, good question. We could probably spend the entire hour on that if we wanted to. So I'll simplify it down to just a few things to keep in mind. So a data lake, if we look at it in its simplest form, is simply a collection of data, right? And the term was born, I think, out of the visual of you've got this empty void somewhere and people just throw a whole bunch of data in, right? And data could be CSV files, PDFs, Excel spreadsheets, JSON documents, right? This could be any data in any form, literally just dumped in a location. Typically, these locations would be like a folder or maybe a bucket in Amazon S3, right? But that's it. It's literally just data of a variety of formats sitting in an arbitrary location. Data lakes have existed for decades, right? Since the early days of data management. Certainly predates my work with data, but you go back probably to 60s, 70s, 80s. Data lakes existed, right? In variety of forms. And this evolution from kind of data lakes to lake houses was born out of this fact that basically a random bucket of data, a data lake, is really difficult to get any value out of, right? There needs to be services and management on top of this data in order to provide any level of value. And so lake houses are effectively the evolution of data lakes into technologies and architectures and services to provide management and optimization capabilities that deliver on helping customers get value out of that data, right? And lake houses, it's a very generic term, and there's tons of products and services and platforms that can deliver lake house type capabilities. But some of these services might be, schema management. So, right, rather than just a dumping ground for a variety of formats of data, lake houses will provide schema management capabilities to make sense and describe this data, right?
Okay.
Lake houses might provide governance and security controls on top of data. Who can access what? Lake houses might provide optimization services to make sure that this, petabyte of data sitting in a location can be efficiently accessed. Right? So all of these services, once they start to be included in your architecture, this data lake effectively becomes a lake house, right? And part of the rationale behind the lake house name was to kind of imply that data lakes are moving into something that starts to look and feel like a warehouse, right?
Right.
So lake house kind of combining the cost efficiency and simplicity of a data lake, but providing enough service and capability that value can be gotten out of that data, kind of like what you would typically expect in a warehouse. So that's my very simplistic definition of it, but certainly we've done entire webinars on lake houses and what they are and kind of how they've evolved. But yeah, just think of it. Most of what we deal with today, by the way, just to kind of maybe drive the point home, Very rarely today is somebody working with a raw data lake, right? Literally just a folder of files with no organization or definition to them. Just about any type of data management that you're going to work with today is probably some form of a lake house, right? And so that's kind of really what the industry has moved towards.
Thanks for that
And Troy,
explanation.
if I can add a little bit to what color to what Jason just said, I would say, and I think he hit kind of these 2 points. One is the structure, right? Like data lake, you can think of it's like there's no really forced structure around the data. Is no structure enforced in storing the data, but Lakehouse has a little bit more structure. Second is like transactional consistency, right? Like lake houses with open table formats such as Iceberg and so on and so forth can give you transactional consistency or asset compliance that is not possible in the world of data lake, right? But I think the most important thing, and really Jason hit on, was it was just a raw dump or a raw store, kind of a raw storage of files. So what it lacked was the governance, the quality, data quality measures, right? So people started referring to data lakes as data swamps because there
Yeah,
was
right.
really, again, no structure, no governance, no quality, data quality measures. That's the beauty of what Lakehouse brings in. It brings in a layer of structure. It brings in a layer of data quality, data governance, data lineage, and a whole bunch of things that you can do on the raw stored data. At the same time, open it up to any query engines, right? So again, it just and the use cases will be slightly different because you don't expect a very good query performance, or you can't expect to run BI use cases or intelligence, business intelligence, or analytics use cases on a data lake, as opposed to lake houses. You can do both data science as well as business intelligence kind of use cases on the lake houses. So yeah.
All right, thank you. All right, let's see if we can get through a few more questions. We can't have 10 minutes on each one and we'll never get there. Next question. Can you access or query data in Qlik Open Lakehouse from the Qlik Analytics engine? And what would be the best way to do that?
Yeah, good question. So yes, the so to provide a little bit of context, Qlik Open Lakehouse ingests data into and optimizes Iceberg tables. So really the question is, can Qlik Analytics consume data from Iceberg tables? The answer is yes. However, it's worth noting that Qlik Analytics in and of itself is not an Iceberg query engine. Qlik Analytics will need to connect to an Iceberg query engine so that it can run queries against Iceberg tables. And there are dozens of them out there, all of which have pros and cons. I would say the simplest is Amazon Athena. So if you have, well, everyone has access to Amazon Athena because it's included in an AWS installation. But Athena is Amazon's serverless cloud native query engine that can query Iceberg, and Athena is very well supported in Qlik Analytics. So very cost effective, very simple to set up and manage. That would be my default recommendation for Qlik Analytics customers who want to query and consume data from Iceberg tables. Snowflake also works, Databricks. There's dozens of query engines that are both supported by Iceberg and by Qlik Analytics. So it's just a matter of what you have access to. But Athena is my default recommendation because, again, every AWS customer, you have access to Athena. It's already there.
And I just want to plug the recent Techspert talk recording with Jason where he demonstrates actually building on Iceberg. So here's the link to that.
Yeah, one of the nice things too about Athena and the way that Qlik Analytics works is Athena is billed by data scanned. It's very inexpensive, just a few dollars per terabyte scanned because of the caching and basically loading data into memory that Qlik Analytics does. You're only going to be billed for those Athena queries when they actually collect and run queries against the raw data. All then the slicing and dicing that you do in analytics, you don't have to go back to the source to do that. So it's a very cost-effective way to get Iceberg data into Qlik Analytics.
Nice, thanks. Next question. When is Qlik Lakehouse going to be available on the Azure platform? The question goes on. Let's see. And what could be the timeline for Qlik releasing?
Yeah, I've actually seen a few questions related to Azure and OneLake and Fabric and what our kind of plans are for supporting the Microsoft infrastructure. Antoine, this is probably a good opportunity for me to punt a question to you.
Yeah, absolutely. Absolutely. So Right now, we only support deploying Qlik Open Lakehouse on AWS. We do have plans as part of our roadmap to support both Microsoft Azure and Google GCP. They are planned for later in 2026, but we are working on that. We are working on that. We will offer solutions for customers who want to deploy their open lakehouse on Azure on one lake, for example.
Fantastic. Thanks. Next question. What does the post-landing process look like after data is landed in the lakehouse?
So yeah, I mean it depends. Well, I should say there's part of it that's necessary, and then there's a lot of it depends on what you want to do with that data. So when we refer to a landing process in Qlik Talent Cloud, whether it's related to Open Lakehouse or not, that's the collection of raw data from a source into files that can then be processed into whatever the final destination might be. So think of landing as raw data, right? If it's coming from like an Oracle database, this is a initial full load or snapshot of a table, and then, effectively redo logs processed into landing so that we have raw data in its raw form. After that raw data is made accessible in landing, what happens in Open Lakehouse is there's something called a Lakehouse cluster. The Lakehouse cluster processes that raw landing data into Iceberg tables. So think of landing as, thousands, hundreds of thousands of raw files. Those files then need to be ingested, converted, and processed into Iceberg tables. Iceberg tables are effectively the data, which is Parquet. So you have Parquet files storing the data itself, and then a set of metadata files that describe that data and its structure and help to maintain all of the capabilities that Iceberg delivers on. So effectively, the post-landing process starts with the Qlik Open Lakehouse cluster processing data into Iceberg tables. Now, from there, what effectively you have is a raw representation of your source data in Iceberg, right? It would often be described as the bronze layer of your medallion architecture type system, right? Data as raw, but queryable and accessible in Open Lakehouse. Open Lakehouse, after it ingests the data into Iceberg, it also kicks off adaptive optimization. That optimization ensures that your raw Iceberg tables are efficient, right? Both in terms of how much storage they consume, as well as how fast you can run queries against them. For some use cases, that's it. That's all you need to do, right? You might be able to connect your analytics engine directly to that raw data and start consuming it or querying it using whatever your query engine might be, right? We've got lots of customers who their primary use case is, I just need to get data from raw, from Oracle, from mainframe, from Salesforce, any of the dozens of source connectors that we support, and I need to then consume it. Other data architectures or other use cases might then require transformation of data, right? We might need to filter and cleanse that data into a silver layer. We might need to join multiple tables together into a data mart or a data product. So, what then happens from there is dependent on the use case. But effectively, think of the data architecture as landing is the source data. The Open Lakehouse cluster then processes it into Iceberg. We optimize that data in Iceberg, and then you can either directly consume it from whatever query engine you have, or you can then kind of push that data through the rest of the medallion architecture tiers. There's a feature we talked about on our last call called data warehouse mirroring. That allows you to make your raw data or your Iceberg tables accessible in your data warehouse so that you can consume it from there, from Snowflake or soon from other warehouses as well. But hopefully that answers the question in terms of what happens after the data comes in through landing.
Thanks. Next question. What's typically the amount or velocity of data that justifies looking at Qlik Open Lakehouse?
Yeah, good question. So, and I'll actually, this question, the same person as the next question too. So I'm going to take them kind of both
Sure.
tandem. The next question is,
That's a big cost saver.
Yeah, and I'll kind of lead into it, but let's start with just velocity
Okay.
of data. Oftentimes, the justification for a technology like Open Lakehouse isn't so much about the volume of data, it is about the velocity of data, right? So if you've got 100 gigabytes of data, but it only needs to be updated once a week, certainly we can do that with Open Lakehouse, but I think the value proposition is a bit diminished. Really, where Open Lakehouse and honestly, where Qlik as a whole really shines is in low latency, quote unquote, real time or near real time data ingestions, right? Those CDC type use cases from relational databases, those maybe Salesforce.com ingestions where you need to ingest data every 5 minutes, streaming ingestions where you might be pulling data from like Kafka or Kinesis. The velocity of data is where ingestion gets really hard and really expensive, right? You could have a use case where you're only ingesting 20 gigabytes of data a day, but if you're ingesting that data in small chunks once per minute because you have low latency real-time needs, that data ingestion becomes very difficult and very expensive, right? So oftentimes when I talk to customers and they try to think through their use cases and try to understand, does my use case fit the value proposition that Qlik Open Lakehouse delivers? I try to get them to focus less on volume and more on velocity and frequency of updates. Certainly, if you're starting to talk about volumes into the terabytes, tens of terabytes,
Yeah.
petabyte scale, no brainer for Open Lakehouse. Any data platform is going to be difficult to manage at that scale. But even if you're working with data in the tens of gigabytes, right? If you have real time or low latency use cases, we have to offer a tremendous value proposition, both in simplicity and cost savings. This leads into the next question about Qlik Open Lakehouse as a cost saver. We just actually yesterday, I believe it was, published a blog. Maybe VJ, you could dig up that link while I'm speaking through it and send it through in the chat. The blog benchmarked a real-time data ingestion, and we compared using Open Lakehouse to ingest the data versus ingesting the data directly to a data warehouse, right?
Ah.
So same data ingested in real time to Open Lakehouse compared to a data warehouse. The conclusion of the blog, oh, I see you're sharing it out. That's great. If you actually scroll that down, just there's a graph in there that I'll use as talking points. Keep going, keep going. That's the warehouse showing queuing and poor performance. Here we go. Those two graphs right above the summary. Perfect. So what this shows you is that for this use case, and this was a I'll say medium volume Oracle CDC use case. We ingested data from Oracle, a few thousand transactions per second. So not trivial, but also not out of the realm of what customer use cases are working with. It was able to show, we compared to ingesting into both an extra small and a small data warehouse. And when compared with the extra small warehouse, so that's the least expensive warehouse option, we were able to deliver 5 times fresher data. So by a magnitude of 5, Open Lakehouse was giving us lower latency, fresher data in the warehouse. And it was done at a 77% lower cost. The numbers are in the blog. It's something like $15 for a day versus $75 for a day of ingestion. So 5x fresher data at 77% lower cost. We then said, all right, what if we wanted to get closer to the same data freshness, right? We needed real-time data in the warehouse. So with the warehouse, we would have to increase the warehouse size. We'd have to go from extra small to small. At the small data warehouse, we were able to get closer in data freshness, not the same. We were still 2.5 times less fresh data. But at that point, it was almost a 90% cost savings. So that data warehouse ingestion was getting to be around $150, where again, the Open Lakehouse was in the tens of dollars. So you can certainly read through the benchmark. A lot of good information in there about how we did the benchmark, what we used to measure, what the configuration of each ingestion was. But the key takeaway is up to 5 times fresher data. So anytime you need low latency real-time data for whatever your use case is, let's say you have analytics that you need to provide on data that's less than, let's say, 15 minutes in latency, we can give you 5x fresher data at up to 90% less cost. So I think those numbers are pretty compelling. And yeah, if you're looking at saving money on data warehouse ingestion, VJ can correct me on the quote, by the way. The stream of consciousness is kicking in right now. At the Snowflake, it was a Snowflake World Tour that we attended in New York City. And someone was on stage from, I believe it was a large financial institution, Capital One.
Yeah.
And they claimed that it was something in the magnitude of like 80% of their data warehouse cost was focused on ingestion. Right, just get
close to like 50%. It's close to like 50%. 50% of, and they spend in the millions, by the way. So 50% of their annual data warehouse spend was just on just getting the data in and storing it. Like ingestion and storage was their biggest chunk of spending from a data warehouse perspective. So imagine if you're able to cut that by 50 or let's say even 80%, like that's huge. That just amounts to millions of dollars for customers.
Yeah. So yeah, exactly. Think of that as an opportunity to shift that cost into Open Lakehouse, see that up to 90% savings. And oh, by the way, you're not just getting savings, you're getting savings plus fresher, lower latency data that can then be, and because of the data warehouse mirroring that we offer, the warehouse can continue to consume that data, right? There's no impact on what you're doing after ingestion. It's just we're shifting that cost from ingesting directly into the warehouse into Qlik Open Lakehouse ingesting it into Iceberg.
Great, thanks. Next question. Why should I mirror my data into Snowflake or Databricks and then make queries there and not directly in Qlik Cloud?
Yeah, so I guess one point of clarification. Qlik Cloud is not a query engine. Right? Qlik Cloud is a solution for data pipelines, data transformations, data ingestion, many of the things that we've touched on here. So if you're going to be consuming data, consuming it for analytics purposes or machine learning or AI initiatives or whatever the consumption use case might be, there will need to be a Iceberg query engine that consumes that data. That could be, again, AWS Athena. That could be Apache Spark. That could be open source options like Trino or Presto. There's a massive ecosystem of query engines, most of which support Iceberg in their architectures. So going back to the question, why should I mirror my data into Snowflake or Databricks? It's if Snowflake or Databricks is the query engine that then drives your use of that data, right? If you're using Snowflake for serving your analytics, or if you're using Snowflake for creating your data marts or knowledge marts, right? Then you would ingest into Open Lakehouse, mirror that data to Snowflake, and then Snowflake can consume the data and do whatever Snowflake does with that data. If you're not using a data warehouse, and you're just looking for an engine that can query Iceberg tables, there's hundreds of them out there. Again, Athena is the one I always gravitate towards, but it's really a comparison point that you can make based on lots of pros and cons, based on whether you want something that's serverless and kind of out of the box like Athena, based on whether you want to roll your own using something like Spark or Trino or Presto. Again, it's a big conversation, but hopefully that kind of helps.
I like the point you made in the Techspert talk recording about how mirroring just means you don't have duplicate data anymore.
Yeah, and that's a good point. We talked about mirroring a lot during the session earlier and even several times today. Remember, if Jason stands in front of a mirror, there aren't two copies of Jason, right? There's not two of me. It's not cloning. A mirror is just a reflection of myself. And that's what a data warehouse mirror in Qlik Cloud is, right? We're not copying the data into your data warehouse. We are simply creating objects in your data warehouse that allow you to query your Open Lakehouse tables. So a single copy of the data that can be consumed by a variety of engines. And that's honestly the vision of Open Lakehouse and where we think we can offer a lot of architectural efficiencies to customers. Let's ingest this data once, let's store it in your Open Lakehouse, let's optimize it so that it's efficiently consumed, and then let's let any of the consumption engines that might be out in the market connect to and consume data from that single location.
All right, next question. Is it possible to implement this with implement Qlik Open Lakehouse with self-managed clusters or VMs instead of using the Qlik managed environments in our VPC?
Probably a good one for you, Antoine.
Yeah. So no, it's not. It's not. The Qlik Open Lakehouse is based on what we call Lakehouse cluster. That's processing technology that comes from Absolver, and it runs only on AWS. We use like the cheapest compute on the market to run the Lakehouse cluster. It's AWS EC2 Spot instances. This is why we are able to show the numbers that we shared with you in the benchmark. This is because we use very cheap compute. And those EC2 Spot instances, AWS can take them back. We have the technology to heal the cluster, to spin up new nodes when they are taken from us. All of that is like transparent for you. It's auto-managed, auto-scaled, auto-healed, so that you don't have to worry about managing your cluster. And we do that in a way that's one of the cheapest way to do that in the market, to run compute in the market. So when
Yeah, and remember with real-time ingestions, this is not like a batch process that kicks off once a day, right? On a self-managed installation, that's not terribly difficult to manage and configure yourself. With any sort of real-time low latency ingestions, you need services running 24/7. They need to be able to go down and come back online automatically. They need to be able to scale out to handle bursts in data volume or decreases in data volume where you need to conserve costs. So honestly, the management of that cluster really has to be a service that we provide to offer on the value that we offer. So some customers say, well, is this something I can just run on my own infrastructure? Honestly, you lose a lot of the value if you even if we did allow for that.
Great, thanks. Next question. How can I monitor what my cluster is actually doing and how it's performing?
So that's kind of related to the other questions. So
Yeah.
The core, the essence of the technology is that the cluster is really self-managing itself and self-healing and spinning up nodes and so on. So all of that is taken care for you. That means there's very little that you as a user or as an admin needs to do to ensure your cluster is working, your ingestion pipeline are working. It's taken care of for you. And you can also go, if you want to monitor the data ingestion process, you can go and open your ingestion tasks and you will see metrics there. You will see data back to what Jason mentioned before. You will see data that's stored as raw level but not optimized yet. You will see data that is still to be optimized and so on. And you will see that progress over time, data being ingested and data being optimized.
Yeah, I was remembering that Jason demonstrated a little bit that you can actually see on the tasks how fresh the data is and the last time it's been updated and how optimized it is. It's pretty cool.
That being said, we are working on adding kind of a monitor UI for the clusters. It's more for your own visibility rather than for you taking actions on that. You can still, decide how many nodes you want to use and so on, but you can do that today, right? It's more for your information and to show you more visibility on what's happening on the cluster. So we are working on that. That will be available in the coming months.
Great, thanks. Next question. if we're migrating a task from Stitch to ClickTown Cloud, is it possible to avoid incurring charges for rows read that are already in Snowflake?
Okay, so that's a little bit off topic.
Yeah.
That's not related to the open lakehouse, but I can give a few ideas, a few hints here. So one thing is that when you are migrating from Stitch to Qlik Talent Cloud, we give you the Stitch subscription for free, so that you only pay for one subscription. So that's one thing here. Moreover, when you are charged by the data you move with Qlik Talent Cloud pipelines, and the SaaS connectors are working the same way, you are not charged for the initial load of the data. So the data you initially load is free, and then
Right, that full
only
load,
the
right?
changes that come over time that are paid. So
Okay.
that should help you with your migration concerns.
Yeah, that's great. All right. Next question. Is there a plan to write back to Iceberg? Snowflake provides write back now, so wondering if this is in the roadmap.
That's a good question. So there's multiple use cases to that. So typically you have one engine managing your Iceberg tables. You can have the Open Lakehouse
Hmm.
manage the Iceberg table, or you can have Snowflake manage the Iceberg tables. Snowflake has what they call Snowflake managed Iceberg tables. We support that, by the way, as part of our pipelines. You can create pipelines in Qlik Cloud that are saving data in Snowflake using Snowflake managed Iceberg. You won't have the same kind of cost saving that we discussed before, but that's an option for you if you want. What you can do, you can have your bronze layer using Open Lakehouse, store this data as Iceberg, and then mirror this data to Snowflake. Then it's up to you to decide how you want to use this data on Snowflake. You can create transformations using Qlik Talent Cloud. You can create another project on Snowflake, which will use this Open Lakehouse, this Iceberg data as a source, and then save the result, the output of these transformations into Iceberg, into Snowflake managed Iceberg. So that will give you like the full bronze, silver, and gold layer, a full medallion architecture on Iceberg. You'll have some layers that are managed by Qlik Open Lakehouse, others will be managed by Snowflake. And maybe that's a good link to another question I've seen here. Let me find that. So that was a question about being able to query the data. Jason mentioned it, so before. Jason answered it before, but I'll add one thing. We are also looking, as part of our roadmap, to support query and transformation on the Open Lakehouse to allow you to do your silver and gold layer with Qlik Talent Cloud Pipeline. So with the Open Lakehouse clusters. So
Okay, yeah, I see that question.
yeah,
Where are
that's
the
part of
silver
the
and gold
roadmap.
layers housed? Yeah.
That's part of the roadmap for 2026. That is allowing you to go beyond your bronze layer with the Open Lakehouse and still continue to use Iceberg and Qlik optimized Iceberg tables as your silver and gold layers.
Fantastic. Thank you.
So there's a lot of combination here. You can pick from among your different layers, different data warehouse you might be using. So there's different solutions. That's the beauty of Iceberg. It's an open format, consumable by basically any compatible query engine.
And I see a couple more questions around roadmap. Let's see. Next question I have found here, are there plans to allow you to stop network integration from within Talent Cloud?
Okay. So that's a very, very specific question.
Yeah.
Yes, there's plans. So the Lakehouse integration is really the link between Qlik Cloud and your AWS infrastructure where the Open Lakehouse runs. We need this link to be alive. It's ensured by an EC2 machine that takes care of the communication between these two networks. So for any production use case, you need to keep that up. Otherwise, you won't have the data flowing back. You can't have any report monitoring from Qlik Talent Cloud. Yes. But for your development environment, you may want to stop that network integration during the night or during the weekends. We are adding that right now as we speak. It should be available in the product in, very soon.
Fantastic. And next question looks a little specific, but I'll read it. Can you offer any help on an error we got while creating a mirror task? Prepare data task failed, job execution failed. The error message says something. Creating a delta source table requires the base location table option to be specified.
Okay.
I would recommend creating a support ticket for something this specific so they can take a deeper look and see if there's anything going on there. Did you want to add anything, Antoine?
No, probably configuration error. Yeah. Open a support ticket and let's have someone look into that for you.
Yeah, that's probably the best path. If you have some more generic questions, there's also on Qlik Community, where is that? The forums. There's some great forums here. This might be in data movement and streaming related to this kind of topic, but we have got over 200,000 users on Qlik Community, so there's a lot of activity out there, and you might be able to get a quicker response if you're not finding a solution to a problem. Next question. Are there any certifications on QCDI with Lakehouse? This one was pre-submitted, so I was able to find a learning module on qliklearning.com. Let's see if I can bring it up here. And there's also some data integration certifications available, but I'll post the link along with the recording here. But this is a learning pathway all about Lakehouse. So there definitely are learning modules here about how you can create that open Lakehouse. So check it out. If you want to go to learning.qlik.com and search here, you'll hopefully find what you're looking for. Next question. Let's see. This one slipped into the chat. You mentioned earlier that even using a query engine on top of Open Lakehouse to ingest the data into a Qlik application, are there any plans to release a connector directly to Open Lakehouse that could optimize that connection?
That's tied to what I just mentioned, the ability for us to add query engine capabilities and transformation capabilities in the Open Lakehouse for handling the silver and bronze layer. That's kind of tied to that. Right now, the recommendation is to use Athena. It shouldn't be a real problem. As Jason said, it's very cost effective, like it's very cheap to use. And because of the way Qlik Analytics works, you will have to just query the raw data initially, and then the rest of the data preparation is done in memory in your Qlik Cloud engine. So it's really the best way to create analytics data on top of your Iceberg data is to go through Athena.
Fantastic. And if you have no further questions, I'd like to thank our panel for today. Thank you all for attending. Thanks for the wonderful questions, and I hope you have a great rest of your day. Thanks, everybody.
Thank you very much.
Thank you.